Good morning, Professor Newell. Angel Rodriguez here. Here to give you my oral report through video because, now we have to do it the old, new school way due to the COVID-19 virus and everything. And the class is being canceled in person. So I'm here in my office, dressed nice for you so you can give me a good grade. So let's get started. My written report is what I drew a lot of inspiration from. And this is it's a lot more detailed than what I'm giving you now because it's multiple pages followed with research and whatnot. So this is basically like some sort of summary drawn from that. I'm going to try to fit into 8.5 minutes for your viewing pleasure and also my grade. The topic I chose was firefighting chemicals. And let's just go ahead and get started. So what is a firefighting chemical? Firefighting chemical, to me, is a chemical or compound that is in some way, shape, or form trying to diminish the factors that go into the fire tetrahedron. So what is the fire tetrahedron? As we usually used to call it, is a fire triangle. So the fire tetrahedron is the multiple factors that are incorporated into what makes a fire, combustion and fuel and everything. That's what keeps it burning. So, the four factors are 1, oxygen, 2, fuel, 3, heat, and the fourth one we now know due to, our, continued research and everything is the chemical chain reaction. So, when we're talking about firefighting chemicals, what they are trying to do is diminish one of those four, as many as they can, honestly, because when we talk about fire tetrahedron, we know now that just taking out one may leave 3 other sources that make the fire continue burning. So let's go ahead and talk about some chemicals that we now use that do this. So the first one is, we've used it forever now. It's found everywhere. It's water. So H2O. It's found all over the planet. It's full of it. It's easy to acquire. It's great. Everybody has access to it. And it attacks fire in multiple channels, which is in different factors. So this is why it's so commonly used everywhere. And let's talk about like a log fire or something like that. So whenever you put water in it, it attacks it first. Let's say you douse it in it. When you douse it in it, it depletes oxygen. It has no way to get that oxygen anymore. And so that's going to put it out. That's one of the legs of the fire tetrahedron. So that's good job, Number 2 would be like heat reduction, because of water's properties. It likes to draw heat from other sources and try to get itself into a state of gaseous matter. So while water's purpose is to become a gas, so it's liquid obviously most of the time, but it will draw heat from fire. It will draw from your skin. That's why whenever you get cold, you get wet, you get cold, because the water is literally sucking the heat out of your body. So that's just an example. Trying to get into a gaseous state, like I said. So that's just an example. So in a fire, whenever you put water in it, it's trying to suck out all that heat and become steam. That's its goal, and it's achieved if it's done that. But the thing is, with water, it doesn't always get the job done. So what do I mean by that? So let's talk about things like grease fires. So whenever you have superheated grease, or let's say a pot, like a pot of oil, and you dump water into it, water and oil do not mix. So what happens is that the water sinks to the bottom, and since it's differently temperature, it has like a violent reaction to where the oil would actually expel out violently and become a gas and therefore ignite, which is what caused a lot of the grease fires at homes. And thanks to advanced technology, we've come out with different extinguishers. The most common one we've seen is ABCs. You can use an ABC on a grease fire. That would, because we'll go into that a little bit more later. But there's also Class Ds, and there's also Class Ks. So Class K, it stands for kitchen, which is meant for, like I said, grease and fatty oils and stuff like that. And the way that attacks it, it's specifically built for grease and those kinds of fires. So the way that attacks it is by attaching chemicals inside of the extinguisher to the fat, right? And it combines to make a soap. So yeah, that's the way it combats. That's super smart because think about it, soap is not flammable. When's the last time you took a shower, you lit a match and you caught fire? That does not happen. You don't, thank God. So that's a great way of combating it. With grease fires, that's the best way to eliminate is with a Class K. And then let's go over what the other classes are. So there's A's and B's and C's, and they're usually combined into one. And what they incorporate is solid objects, liquids, stuff like that. So that's why I said you can use them into like into a kitchen fire, but it's just a different method. It's not as efficient, And then there's the Class Ds, which are meant for metals. So yeah, that stuff's cool. So, and then they all look different. So, I'm pretty sure the Class K is more like a liquid. The Class D, I've definitely seen it. It's like a charcoal. It's like a powder. It's just a amount of sand that just falls out of the extinguisher into the pile. It actually has a handle usually that comes down, so like you're able to like douse it, put it over it, rain it down. And then the ABCs is usually like a dry chemical, that's kind of trying to absorb everything and trying to put out the fire. But that's usually what their main purpose is. And let's talk about some other ones too. Let's talk about in engineering, protection systems. So, like I said, water is most commonly used, whether it's a dry pipe or wet pipe system or deluge, whatever. It's usually water, but there are situations such as server rooms. Google, while I did my internship, I've gotten to see a lot of those. They have, in their server rooms, they have CO2 as their main source of fire protection. So what it does, it seals up the vents and everything. And if it detects heat, it usually has like multiple sensors. So it detects heat, detects fire and smoke, and it shoots a bunch of gas that will stop it from getting oxygen. It will just put it out that way, which is fantastic. The heat's still there, so you kind of have to let it simmer down on its own and everything like that. But that's the great thing about it. And another one was halon, but halon's getting phased out due to the ozone, depleting factors. So that's one of the big ones that we're done with. So yeah, those are the big ideas of the firefighting chemicals, and I hope you enjoyed my video, and you have a good rest of your day, Professor Neal. Thank you.